All right, so here are the answers for our Bellwork. 21, you should have 24. Number 28 is negative 40. Number 29, you end up with negative 8a plus negative 8b. Or you could have negative 8a minus 8b. Number 30, 10b plus 40. And number 31, you could have either one of those for your answer. All right, now let's look at number 32. Find the total cost of 4 yards of fabric. Okay, on this problem, you would take 4 times $8 minus 1 cent. That's the distributive. Find the total cost. When you do the distributive, you'll then have 4 times $7.99, and that will give you the answer of $31.96. Now it says justify your answer by using the distributive property. Well, that's why I wrote it like this. This is the distributive property, and what you would do is you would have $32 minus 0.04, and that gives you $31.96. If this is not clear to you, it's okay. We will practice the types of problems that will be on your future test next week so you understand what to do on certain ones. Sometimes this makes it more challenging than it needs to be. We're going to skip 33 and go on to 34 to 40. In number 34, you're going to have 0.5x times y, add the opposite, plus a negative 0.5xz. All right? Another way of writing that would be 0.5xy minus 0.5xz. Now you can have a 0 in front of there. That's probably a little. Do you see why we cannot combine these? Because an xy is not the same thing as an xz, is it? No, we cannot combine those terms. Now let's go on to number 35. You're going to have a negative 6a times this and a negative 6a times that. All right? Now I'm going to write below this step, and then I'll write the final answer on. Actually, I'll put it below and we'll put the final answer on this line. So you're going to have negative 6a times 2b plus negative 6a times 5c. Now I can take my numbers because it's all multiplying. Negative 6 times a times 2 times b. Because of the commutative property, I can move the 2 over here and multiply negative 6 times 2. Do you see that? The commutative property allows me to do that. So you end up with negative 12a times b. Plus, I can move the 5 and the a because of the commutative property. Negative 6 times 5 is negative 30 times a times c. So that is your answer. Or you could have had negative 12ab minus 30ac. Now do you understand why we practice doing it with numbers before we started doing this with variables? Okay, let's write down the next problem. Here, the first thing I'm going to do is get rid of my subtraction sign. Add the opposite. Negative 4m times 3n. I will write that down, this time negative 4m times 3n plus negative 4m times negative 6p. Everyone have that written down? Does everyone understand that? Now, the commutative property allows me to move these around. So I can say negative 4 times 3 gives me a negative 12mn. Plus, I can move the negative 6 and the m around. Negative 4 times negative 6 is positive 24 MP. And that's our answer. Any questions? Are you writing this down? Good. Everyone should have this written down. You need to show this step because you're still rookies, and then simplify it to this step. After we've done this for a while, maybe in January, then I'll let you start skipping steps if I feel like this class can handle skipping a step. Now, let's go to the next one. This will be 3 times 2y plus 3 times 4z. 3 times 2y is 6y. 3 times 4z is 12z. Any questions? In number 38, the first thing you're going to do is get rid of your subtraction sign. So it's going to be add the opposite. You will have negative 2 times 3a plus negative 2 times negative 2b. Sorry, that's crooked. Negative 2 times 3 is 6a. Negative 2 times negative 2 is positive 4b. Any questions?
No.
Number 39. Add the opposite. Negative 6 times 12p plus negative 6 times negative 8n. Simplify. Negative 6 times a positive 12 is negative 72p plus negative 6 times negative 8 is positive 48n. Any questions? Now, in the next problem, let's see what number 40 is. I know we've not had our geometry unit yet, but you should know what the formula is for finding the area of a triangle. It says write 2 equivalent expressions for the area of the figure. Well, the formula for the area of a triangle is base times height divided by 2. This is your base, this is your height, okay? So you could say 16 times x plus 4 divided by 2, right? Now another one, use the distributive property. 16 times x plus 16 times 4 divided by 2. That would be an equivalent expression, okay? 8, you could have 16x plus 64x. Then you could divide them both by 2. I guess you could have, another one would be, well, we could go on and on, but we have a lot to do. I don't have time to keep on writing different ones. All right, now let's go to our answers. Any questions? Are you getting a better feel for how to do these problems, especially 34 to 39? Okay, now let's go grade your homework problems from yesterday. And we'll just start going to page 379 first. Let's go to page 379. All I have right here are the answers, but if you want me to explain how to do one of them, I will write it in the book and go over that with you. Okay? All right. Number 1, you should have 33. Any questions on that? Number 2 is negative 120. Number 3 is negative 30. Number 4 is negative 10. Number 5 is 4. And number 6 is 6. Any questions?
What a coincidence.
You got them all right?
No, 6 and 6.
Oh, that one. Yeah, that is sort of interesting. That happens every now and then. Okay, now let's look at the next group. This is where it gets a little trickier. All right.
I think that was easy.
3 times negative 4x gives you the negative 12x. 3 times 8 is 24. So do you see how they got 12x plus 24? Good. In this problem, 4 times x is 4x. Get rid of that. 4 times negative 6y is negative 24y. If you had 4x plus negative 24y, that is fine. In number 9, 6 times 5 is 30. Add the opposite. 6 times negative q is negative 6q. So if you had this or this, count it correct. In the next problem, add the opposite. 1/2 times c is 1/2 c, and 1/2 of a negative 8 is a negative 4. If you have 1/2 c plus negative 4, that is correct, or if you have minus 4, that would be fine. Add the opposite. Negative 3 times 5 is negative 15. Negative 3 times negative b is positive 3b. In number 12, negative 7 times d is negative 7d. Negative 7 times 2 is negative 14. You could have negative 7d plus 14 or negative 7d minus 14. Now, in the next problem, in number 13, they want you to use the distributive property. Kids, what they do is they round $6.85 up to $7. That's where they get the $7. Do you see that? And then what's the difference between $6.85? It's 15 cents. That is how they get the distributive property. When they say the distributive property, that is what they do. I will not put a problem like this on your test, I don't think. I'll have to double check to see if there's one on there. So then you take 4 times 7 is $28 minus 4 times 15, which is 60 cents, and you end up with $27.40. Question?
Do you have any like wet wipes for my desk?
All right, number 14. Just take one, that should be fine. In problem number 14, there are 3 people that are going to the movie, so you have $2.25 plus $3.25 plus $4.50 plus $7.50 times 3, and you get $52.50. All right. Did it say you had to use the distributive property? Write an expression. So that you had to write an expression. Yours might not look exactly like mine. Any questions on that? Okay. Now let's go to the other lesson that dealt with properties. And your homework page was 371. So let's go to page 371 and look at what you had to do on that page. The first ones were easy, and then it got a little more challenging. Did you have to do 1 to 8?
These are dry.
No, they shouldn't be. It's just a brand new one.
You did 1, 2, 3, 4, 5, and then 7, 8.
7 and 8, or 7 and 9. I knew there were 2 of them I counted, didn't make you do. Okay, so when you look at this problem, number 1, here we have let me just move my book there.
What page is it?
This is page 371.
I didn't get this one.
Okay, what property? Well, the commutative property says you move things around, right? A, B, 12. B, 12A. They moved things around, didn't they? So it's the commutative property of addition. Commutative means the numbers or the variables move around. Okay? Any questions on that? Here you have 5x plus 0 equals 5 plus x. Whenever you have the 0, check to see if it's the 0 property or the identity property. And in this one, it's the identity property of addition. Remember, the identity property says whatever you add to 0 stays the same. So it's all addition. It's the identity property of addition. It kept its identity. 5x stayed 5 plus x stayed 5 plus x. Any questions? In the next problem, 16C 17. 16C 17. Right away, you know it's not the commutative property because they're all in the same spot. But the parentheses moved around. When the parentheses moved around, here it's around the C plus 17. Here it's around 16 plus C. That's called the associative property. Remember, the associative property has the parentheses that can move around like little snakes. Here, when you multiply something times 0 and you get the answer of 0, it's the multiplicative property of 0. Okay? Did you get it cleaned off?
No. Whoever sits there keeps on writing down a Sharpie marker.
Okay, I will see. I'll try to take care of it after I'm done with this lesson, okay? All right. Number 5, state whether the conjecture is true or false. Division of whole numbers is associative. Well, that is false. And then you have to give an example where it is false. Okay? Well, 24 divided by 4 is 6, and 6 divided by 2 is 3. 4 divided by 2 is 2, and 24 divided by 2 is 12. 3 does not equal 12. So that's their example. So you had to give an example where it does not equal. Any questions? All right, now let's look at number 6. Use mental math to find the total amount of the bill and explain. Well,
we didn't do that one.
okay, the answer is $16.25. Everyone would have a different type of mental formula for that.
I got it.
Now, you had to do 2 of these problems.
I didn't get these.
Okay, let's go over how to do them. We're going to do 7 and 9, and then we'll probably fill in 8 and 10. In number 7, the first thing they did was
I got the first one.
they moved the parentheses. All right, I sort of liked having the 15 plus the 12, so the only thing they did was move the parentheses, so that's the associative property of addition because we're in addition world here. And then you simplify. Okay, so I'll give you a moment to do that. Move your parentheses and write the word associative. Now, if this were on a test or a quiz, I probably would give the steps and you just have to tell me which property it is. So if they move the parentheses, it's the associative property. If you move the numbers or variables around, it's the commutative property, okay? So just look, did they move the variables and numbers, or did they move the parentheses? And you end up with the answer of 27 plus 8a. That's your final answer. 27 plus 8a. Question?
I got something else.
You what?
I got something else that's the same answer.
Okay, but you ended up with the same answer. Make sure, I'll look at what you have because it might be a little different. There could be a couple different things. Now, yes,
I got 35 plus 8. I got 35 times it.
that's not right. You can't, does this say times? It's add, but that's multiplying. You can't take the 8 away from the a because it's multiplying.
I added the 27 and 8 and then put 7.
Yeah, you can't do that. It's 27 plus 8 times a. Now, if that was a plus sign, if it was 27 plus 8 plus a, then you could have added 27 and 8 and ended up with 35a, okay? But it's not, so you can't. Let's look at number 9. First, we move things around. You move the x and the 7. Then you combine. 3x times x is 3x squared. X times x is x squared. So you have 3x squared times 7. Now, since this is like 3 times x squared times 7, since it's all multiplication, you can move the 3 and the 7 around and multiply them. That's where they have the commutative property. 3 times 7 times x squared equals 21x squared. Once again, it's all multiplication. Everything there is multiplication. We're going to practice this some more. All right, kids? It's going to get a little easier as we go on. Let's look at number 8 and 10. In number 8, everything is multiplying. 5 times n times 9 times 2 times n. I'm going to write it out like that. Now, I can take, since it's all multiplication, I can take 5 times 9 times 2, right? And that will give you what? 90. Do you see how I just got 90? 5 times 9 is 45, and 45 times 2 is 90. Then we're going to take n times n. n times n is n squared. And that's how you end up with 90n squared. Okay? We're going to do the same thing to number 10. I think it's easier when you take them apart from their variable. You can see this. So in number 10, let's write 4 times m times 2 times 5 times m. And we can do this because it's all multiplying, right? So let's combine our numbers. 4 times 2 times 5. 4 times 2 is 8, times 5 gives me the 40. And m times m is what? M squared. Any questions on how you get 40m squared? Don't worry about the commutative and the associative steps right now, all right, kids? Sometimes I think that's what makes it confusing. Do you see how we break it down to get that answer? All right, I'm going to put this on pause. All right, page 357, and we have some important vocabulary here that we need to do. On page 357, a sequence. This is what this lesson's about. Lesson 2, sequences. A sequence is an ordered list of numbers. Each number in a sequence is called a term. In an arithmetic sentence, each term is found by adding the same number to the previous term. Complete the graphic organizer below. Well, then you'll just have to wait till I'm done going over this lesson because I need to finish this part. Continue each sequence. 1, 3, 5, 7. What's the next number going to be, class? 9. They're going by twos. Now, in this one, 1, 1.5, 2. What's the next one going to be? 2.5. The next one? 3. And the next one? 3.5. Very nice. Describe each sequence. Well, in each sequence, on the first one, we add 2 to the previous number. And on the next one, we add a half, or 0.5, to the previous term. Okay? Those little dots just mean to write down what I had there. All right, we're going to skip the real world link and go on to page 358. Describe and extend sequences. In an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. Let's look at our example here. Describe the relationship between the terms in the arithmetic sequence. 8, 13, 18, 23. Well, you add 5. It says each term is found by adding 5 to the previous term. And to continue the pattern, you would just add 5. Very easy, right, class? Okay, let's go on to the second one. Describe the relationship here. 4 tenths, 6 tenths, 8 tenths, 1. Well, here they are adding 2 tenths to the previous one. Each term is found by adding 2 tenths to the previous term. Okay, go ahead and do A, B, C, and D. Okay, so for letter A, you do what? You add 13 to each one. So it's 52, 65, 78.
we supposed to do that? Oh, yeah.
So you add 13.
I just put add 13.
Okay. The next three terms for letter B, you add 3. So add 3. It's 16, 19, and 22.
This is an easy lesson.
Add 3 tenths in letter C. So you have 2 and 2 tenths. The next would be 2 and 5 tenths, and 2 and 8 tenths. And in letter D, you're going to add a half, or 5 tenths, and you'll end up with 4 and 5 tenths, 5 and 5 and 5 tenths. You could have 5.0 there. Any questions? All right, let's go on to page 359. In page 359, now we're taking it to another little level. Write an expression for this. How can I show what the expression is? Okay, in a sequence, each term has a specific position within the sequence. Consider 2, 4, 6, and 8. First, second, third, and fourth position. That's pretty simple. So here they have position 1, add 1 to position 2, 3, and 4. In the value, if the operation is times 2, you add 2 to the outcome of each position, and that will give you the answer. So, how would you write it as an algebraic term? It says, you can also write an algebraic expression to represent the relationship between any term in a sequence and its position in the sequence. In this case, if n represents the position in the sequence, the value of the term is 2n. All right, so we're turning the heat up a little bit on the how hard these are. They're still easy though. So in this problem, the operation is 1 times 5, 2 times 5, 3 times 5. So n represents any position, and your expression would be n times 5, or written as 5n, and the value of the term is 5n. I think this will become more clear as we do some more practice problems. Let's go to page 360. It says, if the pattern continues, what algebraic expression can be used to find the number of circles used in a figure? How many circles will be in the 50th figure? Okay, so in figure 1, you have 3 circles. In figure 2, we have 6. In figure 3, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So a possible thing that you could say is for the nth term, it's going to be 3n. 3 times n equals this. Because for this one, 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. So for the 50th one, if we want the 50th one, it'll be 3 times 50, and that equals 150. So here we have our term would be 3n, and for the 50th one, 3 times 50 equals 150. All right, do the guided practice. I'll give you the answers to those in just a moment, and then we'll talk about what your classwork assignment is. If you work hard, there will be no homework, and then we'll watch the video for the fundraiser. Okay, so the answer for 1, add 9, 36, 45, 54. For number 2, add 5, 24, 29, 34. Number 3, add 1/10, 1 and 4/10, 1 and 5/10, 1 and 6/10. Now let's look at number 4. Hannah has a doll collection. The table shows the total number of dolls in her collection for 3 years. Suppose this pattern continues. Write an algebraic expression to find the number of dolls in her collection after n years. Well, in this, it looks like it increases by how much? plus 6. So our term will be times 6. 1 times 6 equals 6. 2 times 6 equals 6. 3 times 6, 2 times 6 equals 12. And 3 times 6 equals 18.
Equals 6.
So it's going to be 6 times n equals the number of dolls. Now, it says, how many dolls will she have after 25? So, we know that this is our expression. If you replace your variable n with 25, you will end up with 150 dolls. Yes. And I used n because it used the variable n right there. That's why I chose the variable n. Okay? Now, what do I want you to do for classwork? On page 361, I would like you to do those 8 problems. Page 361, 1 to 8. Let me double check to make sure we don't have a house problem on page 362. No, that's it. So, do 1 to 8. If you get finished, number 23 is a good problem because it talks about nets here a little bit. We're going to be doing problems with nets in the future. It's a big 6th grade standard that I want you to make sure you understand. So right now, just page 361, 1 to 8 is your assignment.